Good morning to all. Good afternoon to all. Now I am going to explain the.
Good morning to all. Good afternoon to all. Now I am going to explain the.
Now I am going to explain the mass bar spectroscopy. Mass bar spectroscopy. Okay. So in this mass bar spectroscopy, main aim is the new. It is mainly here involving the nuclear transitions. Mass bar spectroscopy mainly involves nuclear transitions. Therefore, the mass bar spectroscopy is termed as a nuclear spectroscopy. Mass bar spectroscopy. Mass bar spectroscopy. So in mass bar spectroscopy, here they mainly nuclear transitions is involvement. So here mainly nuclear transitions involvement. Nuclear transitions. Nuclear transitions involves in the nuclear transitions. Involves nuclear transitions. So therefore the mass bar spectroscopy termed as a nuclear spectroscopy. Nuclear spectroscopy is termed as a nuclear spectroscopy. So here because your involvement of the nuclear transition, therefore termed as a nuclear spectroscopy. The nuclear spectroscopy is developed and he got the Nobel Prize, that is R.L. Masbar. The scientist R.L. Masbar is R.L. Masbar. But he is related to physics topic. In physics, he got the Nobel Prize. He got Nobel Prize. So R.L. Masbar is a discovered in this. He got the Nobel Prize in this contribution in the year 1961. In the year 1961. Okay. So the mass bar spectroscopy mainly resonance emission and reabsorption of gamma radiation. In this case, mainly involves resonance emission and reabsorption of gamma radiation. Resonance emission, resonance emission, and reabsorption of gamma radiation. So in this involvement process is a resonance emission and reabsorption of gamma radiation. So here mass bar spectra is a graph between speed of the source in millimeter per second against intensity of gamma radiation at detection. Yes, intensity of gamma radiation at detection. So here mainly MB spectra is a graph, a two-dimensional graph. So here speed of source in millimeter per second in the x-axis and intensity taking in the y-axis, intensity of gamma radiation in detection. So that is a mass bar spectrum. So mass bar spectrum this generally is represented by a two-dimensional. So in this case here mainly here in this case x-axis taking the speed of the source millimeter per second and intensity of gamma radiation. Intensity of gamma radiation. Intensity of gamma radiation. So we got the plot. So this is called as a simple representation of the mass spectrum. So speed in the millimeter per seconds and gamma rays or gamma count in the y-axis, and here speed in the speed of the source is taking in the x-axis as a units is a millimeter per second. So this is a here mass bar spectrum simple representation. So here setup for the mass bar spectrum or instrumentation. So take a screenshot. So here instrumentation or setup. So in this case, here mainly here four compartments is there. One is a sample placed vessel well, and also source and a detector. Source means the source is producing the gamma rays, and gamma ray counter is present total. Yes, here. So this is a so in this case here which is the source is moving. Source is moving to the source. This is a source is the sample source. So this here source is moving towards the here this is a source for the gamma rays production. So this is a so these are the wheels. So this is moving to nearer to sample and away from the sample. So here which is there the presence of the sample is present. Source is a moving nearer to the sample and away from the sample. This is a source S compartment. So next one a detector. Detector is this one. Detector. So this is a detector. So therefore what happened? So this is a detector. Detector here in this detector here gamma ray counting gamma ray counting. So this is a what happened. Source is one time moves to the towards the sample, another time is a moves to away from the sample. So that's why this is a flexible nature. So this is a MB spectroscopy setup. Mass bar spectroscopy setup. So in the mass bar spectrum can be obtained by irradiating this sample with the gamma radiation that is coming from the source. This is a source. The source is a moving towards the sample or away from the sample is there. So then move towards sample or away from the sample and counting the gamma radiation with the help of the detector, gamma ray counting with the help of detector. So this is a which is the setup of this one. So here what happened? Here source is moving towards the sample or forward direction, move towards sample. Here indicates by the plus sign, and here source is away from the move away from the sample, that can be denoted by the minus. So we have this some gamma ray count values. Yes, here mainly this is a mass bar spectrum setup. So here mass bar spectrum applications. See here, MB spectra is considered the resonance absorption and fluorescence. Resonance absorption and fluorescence spectra. This spectra is obtained by R.L. Masbar in the year 1958. Because of this, he was awarded He was awarded Nobel Prize in the year 1961. This MB spectra is utilized the nuclear properties to get into the above environment surrounded here nuclear environment surrounded by the nucleus of the atom. There are the there are variety of applications in various fields. Various fields, for example, solid state physics and metallurgy and biochemistry. These applications is mainly three areas: solid state physics, metallurgy, and biochemistry. The MB spectra is useful to estimate iron, tin from its ores and alloys and waste materials. So iron, tin, yes, here mainly estimate the spectrum MB spectra useful to detect iron, tin from their ores, alloys, and waste materials. So the MB spectra utilized to detect the percentage of the different charges. Yes, it is detected to a percentage of different charges, like as a Fe plus 2, Fe plus 2, Fe plus 3, yes, Sn plus 2, Sn plus 4. How much percentage is present each S ion, that percentage can be detected by the MB spectroscopy. Okay, this it is useful for the study of the S bonding which is formed between the atoms. It is also useful for the study about the bonding which is formed between the atoms bonding. So next one, it explains the magnetic properties, like as a magnetic interactions can also be studied in different compounds. Magnetic interactions can also be studied in different compounds by using the MB spectrum. Okay, it is a very much powerful tool to determine the electronic structure of a molecule. Electronic structure of a molecule. The MB spectrum is very much a powerful tool to determine the structure of a molecule. That is called as a structural information. The mass bar spectrum gives the structural information also. Structural information. Next year, in this mass bar spectrum, here nuclear transitions is takes place. Nuclear transitions is takes place. That results from resonance absorption of resonance absorption of recoil-free gamma radiation by the sample. S. It involves nuclear transitions that results from resonance absorption of recoil-free gamma radiation by the sample. So, in the mass bar spectrum, here transitions are characterized by the charge in nuclear spin quantum numbers. The charge in nuclear spin quantum numbers. Please take a diagram. So now I am stopped here.